Hello, everyone, and welcome to week 2 of our online lessons. This time I'm going to just record this directly. You don't really need to watch the Algebra Nation videos if you don't want to. I'll cover all of the same information they're going to cover, kind of break it down a little bit more. I know I had a lot of people that told me that they weren't quite sure exactly how to do certain things in the last section. Again, that was just kind of like, hey, let's learn how to do the online thing, how to get onto Algebra Nation, how to see the check your understanding problems, which is going to be the primary way that you guys send work to me. One thing that I do want to let you know is that um, anytime you want to see what you're supposed to be doing, you can check on Student Portal. I'm going to make sure that I put a very detailed description of every assignment, including links and everything in the Student Portal. So if you want to check in there, you should see exactly what you're supposed to do, even though I'm going to tell you in this video again. It's just that way it's a persistent place where the information will be, rather than, if I send something out on Remind, it's very easy for somebody to miss like a single message. So anyways, we are starting a new module. This module is called Statistics. It's supposed to run from April 6th to May 1st. Um, April 6th is this coming up week here, I believe Monday. So we're going to go ahead and get started right on time with this module. Hopefully, we end on time. But as you see before you here, there's the schedule. This week, we're going to be talking about populations versus samples, sample surveys, experiments, observational studies, randomization, and bias. Week 2, we will be talking about normal distribution models. Week 3, we'll be talking about estimating means and proportions and margins of error. And week 4, we're going to be talking about comparing treatments and interpreting data. All right, so we're going to go ahead and get started on this. So first things first, statistics is an awful lot like geometry. They're not anything alike, except for the fact that they are very, very, very vocabulary heavy, and there's a ton of symbols. On the left, you see some of those symbols. I hope I'm not having given anybody some geometry flashbacks here, but some of the symbols that you saw in some of the words that you saw in geometry, and on the right, here are some from statistics. You don't need to write all these down now. As we go through the lesson today and throughout this module, I'll make sure anytime we see a new word, I'll explain to you guys how that word works. If there's a symbol attached to it, I'll give you that as well. But we're just going to be working our way through. Okay. So first things first. All right. So first, suppose you want to know the average number of TV shows students in your class watch. You surveyed your entire class and concluded that they watch 2.4 shows on average. Now, what a population is um, like everybody, all right, everything. It doesn't have to be people, but if you wanted to do a study on um, how many sharks have a certain, or how many, let me give you an example, how many boxers are a kind of dog, and they're also known to have deafness issues. So if you wanted to figure out how many boxers were deaf, the population would be every single boxer. Um, of course, there's no way for us to know every single boxer whether he's deaf or not. So, population, even though it's generally everything, is usually not a group of subjects that we can actually talk to or survey or take data on every single one. A parameter here is something about that population. So, for instance, up here, the population is all of the students in the class. Well, if your class is only 20 or 25 people, that's not that hard to figure out to ask every single student in the class, how many television shows do you watch? And this 2.4, this parameter right here, that is something to describe the population, all of the people in the class. So many, many, many times we have no idea what the parameter is of something. But if the population is somewhat small, we can know it. Now, what we're going to do now is we're going to change this slightly. It says, suppose you want to know the average number of TV shows students in your school watch. You surveyed 100 students and concluded that they watch 1.9 shows on average. So, did we talk to every single student in the school? The answer, of course, is no. We only talked to 100. This is what we call a sample. So, the study of statistics, what we want to do is we want to grab a portion of people that are representative of all the people, or if we were testing a product, let's say we manufacture radios or stereos in a factory, that particular company may not test every single radio that comes off the line. They may test every 10th radio or every 100th radio. Again, that what they're doing there is sampling. All right, so they're taking a smaller group from within a larger group, because testing every single item or talking to every single person in your school would just be a monumental undertaking. It'd be very hard to do. All right. So here our sample is these 100 students, and the statistic is 1.9 shows. So when you're talking about samples and statistics, they're just a part of populations and parameters. Parameter is something that describes a population, while a statistic is something that describes a sample. This is what we will be doing most of here. We use very little populations and we use very little parameters. All right. Now, here is where we're going to start to get into some of the symbols. Okay, guys, there's lots and lots of symbols. If you look at this table, you can try to replicate this in your notes. But all of the things that are on the left-hand side comes from, these are statistics about samples. And what they are trying to estimate is parameters about populations. All right. So again, these here are estimates of what the true value is, but as it says down here, statistics vary from sample to sample, but parameters are fixed constants that are usually unknown. Again, there is absolutely a certain number of boxer dogs out there that are deaf, a percentage of all boxers that are deaf. We have no idea what that number is, and we will never know what that number is. But we can do statistics if we were to randomly gather 100 boxer dogs and then we gave them tests and figured out there was, 12 of them that were deaf. Well, now we know that our statistic states that 12% of boxers are deaf. Now, again, if we got 100 other boxers, we may not get 12 anymore. It might be 15 or it might be 8. It can, these values change depending on our sample. But what we're trying to estimate is what the true parameter is, which again, we just generally won't have any idea of. So here's some of the symbols that we're going to get here. Let me see if I can get my marker here. Da, 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 da. Mm-hmm. I guess I got to do this to get my pen. All right. Let me go back to full screen here. Okay, so first, sample proportion. This is what this looks like. It's called p hat. It's p, and it's got this little, it's called the caret on it. If you look on your keyboard for your computer, it's right on the 6 key usually. If you do shift 6, you get this little hat thing. Okay, so this is p hat. This is the sample proportion. So again, if we gathered 100 dogs, 100 boxer dogs, and we found out 12 of them were deaf, that would be 12%. P hat equals 12%, or 0.12. All right, now what that's trying to estimate is p. That would be the parameter of the population. All right, and again, these are percentages. Now, means, we know means are averages, okay? For the sample mean, might go X bar. Now, this is going to be a little bit different. We'll talk about this a little bit further down the page, but this is going to be a little bit different here. This is going to be on a different type of data. For instance, we wouldn't be doing something like whether a dog is deaf or not. We might be with our shows that we did before, 1.9 shows, that was an average, that was a mean. So this is used with numerical data, while this here is used with whether you fit in, whether something is true about a person, a dog, a subject or not. Okay. And again, what this is estimating is going to be this. It kind of looks like a U. It's a weird looking U. Let me see if I can make that a little bit better. All right, something like that. It's kind of like a U. That is the population mean. Again, this is a number that we're probably never going to know. All right. Then we have sample variance. All right, that is S squared. Sample variance means how, how varied the data is. Sometimes we're not going to get exactly the same value all the time, so that's called sample variance. We have population variance. This is another Greek letter, sigma. sigma squared. Um, Sample standard deviation. We are going to be talking about standard deviations a lot in this module. So sample standard deviation is just S. It is the square root of this. And population standard deviation is sigma. It is the square root of this. All right. So these are just some of the symbols. Write them down. We won't be using all of them. Again, we're primarily going to be dealing with stuff that comes from samples and statistics and not so much from population. So it'll be mostly over here. Again, at the bottom, please make sure you understand parameters are numbers that we don't actually know most of the time. All right. So first it says, what type of data are proportions used for? Guys, there's two types of data, and I know you need this for sure on your first check for understanding problems. What types of data are proportions used for? Proportions, like for instance, we talked about that 12% of boxer dogs that might be deaf. That is going to be used for categorical data. Categorical data. For instance, it's whether something is something or not. If you wanted to find out whether or not a student owned a smartphone, they go into two categories. Owned a smartphone, does not own a smartphone. That's categorical. If you wanted to figure out if a student ate lunch in the cafeteria or not at school, they either eat lunch in the cafeteria, or they don't eat lunch in the cafeteria. They're just fitting into categories. Um, the means up here, what type of data does that describe? It describes quantitative data. Okay, quantitative data. Quantitative means how many. So, for instance, if you wanted to figure out um, how many games a student owns, like if they have a console like an Xbox or a PlayStation, that would be quantitative. The answers here are going to be numbers, numeric. So there's two main types of data, categorical and quantitative. We use proportions for categorical, like a percentage of things, while this one here is kind of like a total. We're counting things up, all right? And when we do take a sample from a population, we want the sample to be randomly selected and representative of the population. We don't want to cherry pick. It's called cherry picking data. We don't want to pick data that follows with or kind of goes along with the way that we want our data to look. We want accurate data. And in order to get that accurate data, we randomly select our samples, but we want it to be representative of the entire population. All right. So, for instance, if I wanted to figure out the average grade in my class, I wouldn't pick the 5 highest graded students in my class and say, hey, an average student in my class has a 97 or a 98. My data would not be accurate if I did that. All right. So I would want to randomly select students. All right. So we're going to have a practice little question here. It says, the human resource manager at a large corporation with 200 employees wants to estimate the proportion of its employees who have children. The result of a survey are shown below. So again, guys, this is categorical data. Either the people have children or they do not have children. We're not asking them how many children they have. They either have them or they do not. So they have 200 employees. It appears that they talked to 40 people, all right? 16 of which had children, 24 did not. 16 plus 24 is 40. All right, so what is the population? Well, the population, again, is all of the employees. That's right here, 200 employees. So the population is the 200 employees. All right, what is the sample? Well, we talked to these 40 people. So the sample is the 40, oops, I don't know why that's not writing anymore. All right, but the sample is I guess if I do that, the sample is the 40 employees. I lost my pen. Try that again. All right. The sample would be the 40 employees that we talked to. 40 employees we surveyed. All right. Now, what is the parameter and its value? The parameter. The parameter would be, as it says right here, the human resource manager at a large corporation with 200 employees wants to estimate the proportion of its employees who have children. So, out of all of the employees, the population, how many of them have children? That is something that we do not know. All right. That would be the parameter. The parameter is the percentage or proportion of employees at that corporation that has children. And that, again, is something that we do not know. All right. What is the statistic of interest and its value? Again, statistics apply to samples only. So we had 40 employees we surveyed. We're trying to figure out how many of them have children, and that appears to be 16. All right. So the statistic of interest would be 16 out of 40. Okay. That, of course, again, would be p hat. All right. And 16 out of 40, that's what, 8 out of 20, which is 4 out of 10, which is 40%. Okay. Um, it says the human resource manager concludes since 40% of the people in my survey have children, exactly 80 of the 200, in other words, 40% of his employees at the company, must have children. Guys, think about that for a second. What is the flaw in this reasoning right here? That if 40% of the sample had children, then 40% of the population is going to have children. Think about that for about 5 seconds here. Well, the flaw, hopefully, I hope you figured it out, was that, again, samples vary. Samples vary. So if we had talked to a different set of 40 employees at the company, um, we may have a completely different percentage. So while 40% may be somewhat accurate, it's not going to be exactly 80 people. All right. So, again, samples vary. There's always what we call a randomness or a variability to samples that we just don't know exactly how far away is from the actual population. All right, here's another question. A light bulb manufacturer claims that the average lifetime of their light bulb is 850 hours. After sampling 100 of their light bulbs, the average lifetime was determined to be 825 hours. So, again, what is the population? I'll let you guys try to answer that. What is the sample? What is the variable of interest? What is the parameter? And what is the statistic of interest? All right. So again, what is the population? That is all of the light bulbs they manufacture. Again, the population is everything, all of it. Okay. That's the population. What is the sample? Well, right here, after sampling 100, it's these 100 light bulbs. That's the sample. All right. What is the variable of interest? What is the thing that we want to know here? Well, it's the average lifetime of the light bulbs. That's the variable. That's what we're interested in. All right. What is the parameter? Again, parameters apply to populations. Parameters apply to populations. So the population here is all of the light bulbs that they manufacture. And what did they say? The average lifetime of their light bulb is 850 hours. So the parameter there is going to be 850 hours. What is the statistic of interest? Well, the statistic of interest would be the light bulb or the average life of these 100 light bulbs that they talked about, right? And the statistic of interest that we came up with was 825, okay? Out of these 100 bulbs, they found out the average lifetime of these was 825 hours, all right? A school newspaper, one more here. A school newspaper published a story that included the results of a survey of its juniors and seniors. There are a total of 300 juniors and seniors enrolled at the school. So figure out, let's see how many people they talked to here. All right. So they talked to 80 people. All right. First, we want to identify if this data is categorical or quantitative. Did they ask them a categorical question or a quantitative question? Did they ask them a how many, or did they ask them something that puts them into a category? All right. And this data here is categorical. All right. There's two categories: going to prom, not going to prom. Those are the categories. So this is categorical data. All right. Now, what is the population? Again, the population is everyone. So that would be these 300 juniors and seniors. That is the population. What is the sample? Hopefully, you realize it's these 80 people. All right, that is the sample. What is the variable of interest? Again, what is the thing that puts them into different categories? It's whether they are going to prom or not going to prom. So, and I would say that we're really interested in the ones that are going to prom. If you're not going to prom, we don't need to worry about how much food to give you. We don't need to worry about making sure there's enough chairs there. This is going to be the one that's the most important here, is the going to prom. What is the parameter? Well, the parameter, again, parameters apply to populations. And again, this is the population. The parameter would be the number of students, juniors and seniors, that are going to the prom. This, again, is a number that we do not know. All right. It is an unknown data value, just like most parameters always are. What is the statistic of interest? Statistic of interest, okay? Well, we found out that 20 of the 80, all right, because that's the total, 20 plus 60 is 80. So we know that 20 of 80, all right, 20 out of 80, and again, that's going to be our p hat. 20 out of 80, or that looks like 1/4 or 25% of these juniors and seniors in our sample that are going to the prom. All right, that is our statistic of interest, 20 out of 80. All right, now you should have enough information and knowledge to do the check your understanding problems for section 12, topic 1, statistics and parameters. There is a very, very important grading update. Please do understand, guys, on that first one that I had you do this past week, it was only about really kind of getting you online. You got a 100 no matter how good or how bad you did. So you're going to be graded this week and on future weeks on your best score only. You can redo those check your understanding questions as many times as you want. It does let me know how long you spent on each one, so make sure you're not just kind of like whipping through it, seeing what the answers are, and going back through. If that's the case, I'm going to start having to do something to, even that out. Maybe give you guys some other work or something. But this is how the grades will be entered right here for all assignments in the future. We will be doing some sort of assessment, quizzing, testing in the future, but not quite yet. And we'll get to that when we do. But this is for your assignments. So whenever you do those check your understandings, they're 3 questions long. If you get 3 questions right, you're going to get a 100 in the grade book. If you get 2 of them right, that's really 67%. I'll give you an 85. If you get 1 of them right, that's really a 33. I'll give you 70. But if you don't do the assignment, you're going to get a 0, of course. Again, you're only going to be graded on your best score only. So if you take it, 3 or 4 times, and that's how many times it takes you to get to all 3 right, then please do it that many times. Okay. Make sure you, when you review the questions, you can see parts that you should go back over. All right. It'll take you to the parts, video, and it'll give you solutions on how to do those particular questions. Right. So you want to pause video now and then go do those questions. Please do go right ahead. And the lesson will continue after you finish those questions. Okay. All right. So the next topic is section 12, topic 2, statistical studies, part 1. Statistical studies can take on many different forms that we'll talk about in a few minutes, but they all fall into 3 main categories. All right. The first one is called a sample survey. And sample survey just means you are, collecting your data by basically asking questions All right, this could be in person, this could be over the phone, this could be an email. Um, if you're dealing with objects, well, again, sample surveys are mostly about people. So it's really about asking questions, getting data from people. All right. An observational study an observational study is when we're using data that already exists and we're just observing it. For instance, let's say you started to work for the Auburndale Police Department and they wanted to find out what percentage of crimes committed in the city were misdemeanors. Well, what you could do is you could look at the data that already exists, all right, and you could just start collecting that data just by looking at it, all right, and you would just count it up. But the big thing here with observational study is we are looking at data that already exists. Okay. Third type is an experiment. Now, an experiment, we are creating data, all right? We're applying, with an experiment, we may want to find out what is the best. There's a YouTube channel that I watch all the time called Project Farm. And this guy always tests different types of products. And one of the most recent ones that I saw, he was testing different kinds of bed liner spray. The spray you can spray into the bed of your pickup truck in order to protect the bed of the truck. And he sprayed a bunch of different types on a pickup bed, and then he tried to scrape it and tried to do different things. None of that data existed when he started. He was doing, he was using different materials. He was experimenting with different things. That's what an experiment is. But the big thing here is that we are creating data, all right, it's called applying treatments. I know that sounds medical, but it is not. It can be, but it is not. So we're applying treatments. So if you wanted to figure out, for instance, um, you know, uh, what the best, what your favorite kind of apple is, for instance, you might go out there and buy a bunch of different types of apples, and then do like a blind taste test and figure out which one you like the best. All right, you are creating data that does not exist yet. That is again an experiment. All right. Now, when you are doing experimental design, you need to have these three principles in mind. First, randomization. Okay, so we're talking about creating an experiment here. First off, that's the last one that we just talked about right here, experiments. First thing, randomization. We use chance instead of personal choice to assign experimental units to the treatments. Now, what this says is it minimizes bias. Guys, this is a vocab word. This is a word that we need to know, bias, okay? Well, this is also a vocab word, but bias means that we are, we're not, um, we're not going to be influenced. All right. Bias means that you are being influenced. So, for instance, if I were to walk around the school and try to get everybody's favorite flavor of soft drink, if I said something, hey, your favorite flavor of soft drink, it's Coca Cola, right? It's Coca Cola, right? It's Coca Cola. It's not Pepsi, right? It's Coca Cola. I'm introducing bias into the question here. Okay, I'm kind of making that person think, hey, this person wants me to say that I like Coca-Cola the best, right, rather than Pepsi. That's called bias. Okay. Randomization also evenly distributes the effects of lurking variables across all treatments. Okay, this is another vocab word. I told you there was a lot of vocab in this. Okay, now lurking variables, and there's also another one. Let me see if it's on this page down here or not. Da, da, da. Yep, it is. So we'll talk about that then. All right. Well, let's talk about them both at the same time. There's this one right here that says lurking variables, and there's one down here that says confounding variables. These two things are actually the exact same thing with one small difference. Okay. So there was a study that an experiment that they did a while back where they were trying to figure out supposedly if you drank a bunch of water, at least 10 8-ounce glasses of water per day, you get sick less often. And so they conducted an experiment, and they had one part of the group not drink 10 8-ounce glasses of water a day, and they had the other group drink 10 8-ounce glasses of water per day. And over time, they did realize that the people that drank the 8-ounce glasses of water did get sick less often. They found out that was actually true, that people that drank at least 10 8-ounce glasses of water per day did get sick less often. The problem is that there was a lurking variable or a confounding variable in the experiment. The problem is that these people who were drinking 10 8-ounce glasses of water a day had to go to the bathroom a lot, because if you drink water a lot, it makes you go to the bathroom a lot. And what they were doing is when they left the bathroom, they were washing their hands. And the washing of the hands is really what caused those people to get less sick less often. Okay. Now, how would that be a lurking variable or a confounding variable? Well, first off, it's something else that's having an effect on our experiment that we didn't plan for it to have an effect. It's not part of our study. That wasn't part of the study. It's something else that's affecting what's happening. The only difference between whether it's lurking or whether it's confounding is whether or not we recognize it and include it in our study. So that one was actually in that study a confounding variable because they actually realized, oh, this is what's happening, and they included that information in their study. If it had never shown up at all, then it would be still classified as a lurking variable. Lurking kind of means, peeking around the corner, it's there, but nobody knows it's there. So that's the big difference between lurking variables and confounding variables, is whether or not we recognize that they're actually there and we can identify it and we can discuss it. Okay, so that's the big difference. So randomization is important. Replication is also important. To replicate something means to do it over and over. All right. So replication means we're going to assign multiple subjects, experimental units to each treatment. So in other words, if we were going to try to figure out whether or not um, let's say we were doing again a taste test on soft drinks. You're not going to pick one person to taste the Coke products, and one person to taste the Pepsi products, and one person to drink something else. You're going to assign 5, 10, 15, 20 people to each group, because what that's going to do is that's going to reduce our chance variation. In other words, we're averaging out just luck, and that larger samples produce more precise estimates of response differences. So again, the larger the sample, the less variance we're going to have. All right, it's going to tighten everything up. You need to have a they call that replication. And finally, we have something called control. Control allows the experimenter to reduce the effect of confounding variables, which we just talked about. We use a control group and or a placebo group to blind or double blind your study. Um, these are a couple more vocab words here. Blinding a study. If you blind a study, let's say you were doing a study on whether certain, treatment A or treatment B is, let's say you're doing a cancer study. Um, if you were to blind your study, some of the people that were in the study, they would receive cancer drugs, the experimental drug. Others would receive a placebo, which is kind of like a fake drug. It's not doing anything. All right. Um, but the people that are taking place in the experiment, the subjects, all right, the patients, they would not know whether they got the good drug or whether they got the placebo, the fake drug. A double blind study means that the doctors that are involved in the study, they don't know either. All right. So they wouldn't know which uh, patients are getting the good drug and which patients are getting the placebo. So they would make, the experimenters would make the pills look exactly the same, the drug look exactly the same for both, and nobody in the study would know if it was double blind. The only people that would know would be the experimenters. Those are not the doctors, by the way. Those are the statisticians. Those are the ones that are conducting the study. So again, control helps reduce biased results. It makes groups as similar as possible, except for the treatments they are comparing. So that's called controlling. Again, that's when you take some group and you don't do anything to them. Others, give them the good cancer drug. The other one, you give the fake cancer drug and different things like that. So you have a control group. All right. All right. So here's some examples here. For questions 1 through 3, classify each situation as a sample, survey, an observational study, or an experiment. And identify any problems with the method of data collection if one exists. Sometimes it may not exist. So here's the first one. Study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys played The Legend of Zelda, and 20 randomly selected girls played Super Mario. The time it took them to reach a certain level of expertise was recorded. All right. So is this a sample survey, an observational study, or an experiment? All right. And is there a problem with what they did here? All right. The second one. For your statistics project, you collect data by posting 5 questions on poster boards around the classroom and record your classmates' responses to them. Okay, again, is this a sample survey, an observational study, or an experiment? All right. And is there a problem with collecting data this way? All right. And then finally, the last one. 50 recent graduates will be randomly selected, and their starting salaries and college GPAs will be recorded. The researcher wishes to investigate the relationship between starting salary and college GPA. Again, is this a sample survey, an observational study, or an experiment? Okay. And is there any problems with this collecting the data this way? So let's go. Oops, sorry. Let's go through these. Actually, I think I've got this right here. Yeah. So a study investigating this, they had 20 boys play this Legend of Zelda, 20 girls play this Super Mario. Guys, this is an experiment. This data does not exist yet. All right, so this is an experiment. Now, are there any problems? Are there any problems? Okay. Yes, there is a problem, right? Problem is there's no control. They pick different games, guys. There's too many different variables going on, all right? So they pick different games. Those games may not have the exact same difficulty, all right? The Legend of Zelda is quite a bit more difficult than Super Mario, so they're different games. They're tilting the study a certain way, all right? Question number 2. For your statistics project, you collect data by posting 5 questions on poster boards around the classroom and record classmates' response. Guys, this is a sample survey. Okay, we're asking questions to people basically. Are there any problems with this data? And the answer is yes, there is problems. The problem that we have here is maybe not all of your classmates are responding to all of these. This is what we call a self-selected survey, and they're never good. They're always biased. Um, so here the problem is we're going to have bias issues here. I'll explain that a little bit more when we get into our different types of um, collecting data, or different. It's called sampling techniques. But bias, anytime you have the subject themselves decide whether or not to be a part of the study, is when you have bias issues. All right. And finally, 50 recent graduates will be randomly selected, and their starting salaries and college GPAs will be recorded. The researcher wishes to investigate the relationship between starting salary and college GPA. This is an observational study. Why is it an observational study? Because the data already exists. Their starting salaries are what their starting salaries are. Their college GPAs are what their college GPAs already were. Guys, this is data that already exists and we're just observing it. All right. As far as problems go, I don't see any problems with this one. I don't see any issues with bias. It says that they're randomly selected, so the randomness is fine. So, yeah, that appears to be fine. Okay. All right. For questions 4 and 5, we're going to classify each situation as sample survey, observational study, or an experiment. We are not going to describe any problems or anything like that. It didn't ask for that. So first, the local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 of the stretches of road and paint B to the other 10. The department finds that paint B lasts longer. Guys, this is like those markings that you have on the road, yellow lines, white lines, and all that on the road, the stripes. I believe, if I'm not mistaken, on I-4, there's a stretch of road on I-4 just to the west of Lakeland that if you're coming in towards Lakeland from Tampa on I-4, there's all these stripes painted on the road all the time. And I think that's what this kind of might be, where they're testing different types of stripes, different types of paint to see which one holds up longer. Well, guys, is this a sample survey, an observational study, or an experiment? Think about it. Okay, so this happens to be an experiment, guys. The reason it's an experiment, um, they're this data doesn't exist yet. They're taking the paint, they're putting it down. They are observing what's happened. That's how I know a lot of students get the experiment and observational study mixed up because they are observing what's happening. But again, this data did not exist at the beginning. That's what makes this an experiment. All right. All right. Researchers visiting public high schools found that 75% of the students use computers in their classroom work at least once a week. The researchers visited a total of 50 schools in 15 states. Again, sample survey, observational study, or experiment. All right. This is an observational study. Why is it an observational study? It's because this data already exists. Okay, this data already exists. I know some people might say it could be a sample survey. It kind of, I could see how this could be either observational study or a sample survey, depending on how they got this data. If they were looking at data that already existed at the schools, then it's an observational study. If they are interviewing teachers and interviewing students and getting this data, well, then it's a sample survey. So it depends on which way you read this question as to whether it's observational study or sample survey. What we can tell it is not is an experiment. All right, they're not, controlling. They're not having, some of the students do one thing and some of the students do a different thing. They're not creating new data. They're just recording data that already exists. All right. And now is when you should be able to do the check your understanding or CYO questions for section 12, topic 2. All right. This again is in the Math Nation. It would be the second part of section 12. All right. Um, do those questions. Pause the video now. Um, Again, I know this is an awful long video, guys. This is for the entire week. You do not have to do this all at one time. You can come back to it later. All right. All right, so we are moving along to, forgot I was not in full screen anymore. You guys might hear my dog barking in the background. That's actually my wife's dog. She's that dog is annoying, so just ignore it. All right, so section 12, topic 3, statistical studies, part 2. What we're going to learn is we're going to learn how to collect data with different sampling methods. Um, one of the main factors in collecting data is whether or not that data is biased. Remember, biased data is bad data. All right, we don't want it to be biased data. So it says certain sampling methods are more susceptible to being biased, and we're going to determine whether or not each of these sampling methods is likely to produce biased results. All right, so first, simple random sample. Every individual in the population has an equal chance of being chosen. All right, so we're going to find out whether this is biased or not. So let me give you an example of each one of these as we go through. An example of simple random sample. So let's say that at Auburndale High School, they wanted to figure out what students thought of the school lunches. All right. A simple random sample way of doing this would be every single student at the school, their name is put into, let's say, Microsoft Excel, or let's say there's a number assigned to each student. All right. And they randomly selected numbers of students that they wanted to talk to about school lunches. All right. So, let's say the first student, their number is 0001, and the next student, their number is 0002, and the next student, their number is 0003, all the way up to 1000, whatever number of students we have. And then they used a random number generator to generate, let's say, 50 numbers, and those are the numbers that we're going to talk to. All right, that would be non-biased data. That data would not be biased. All right, so that this is a good way in order to collect data that is not biased. All right. The second method is called cluster sampling. The population is divided into groups called clusters, and a simple random sample of the groups is selected. So, an example of this might be maybe the group of the entire school is too big. All right. So what they did is they broke all of the people down in the school, let's say, into groups of 100. All right. And then out of those groups of 100, they did a simple random sample from within those groups. All right. So it's kind of the same thing as what we just had, except you're just breaking the bigger group into a smaller group and then picking the random samples from those smaller groups. Okay. So when we break it up into groups, that doesn't mean that we're going to pick one single group and then everybody in that group is going to be sampled. That is not what we're talking about. Um, you know, we're just, randomly sampling. Now, would that produce biased data? Yes, no. The answer is nope. That would not produce biased data, right? So again, this is another good way to get some information, all right, to collect some data. The next way is called stratified sample, all right? The population is divided into smaller groups called strata that have something in common. Then a random sample of each strata is taken. Now, let me give you this one here, stratified sample and cluster sampling. Students get these two mixed up all the time. The biggest difference between them is, yes, on this one you are taking a larger group of people and splitting them up into smaller groups, and you are doing the same thing here. But the biggest difference is this one, these have something in common, all right? These smaller groups. So, another example with Auburndale High School. Let's say we took all of the students at Auburndale High School and then we split them up into groups by grade level, all right? And we got this one group that's nothing but ninth graders, and this other group that's nothing but 10th graders, and this other group that's nothing but 11th graders, and this other group that's nothing but 12th graders. That is called a stratified sample, all right? And then within those samples, let's say we pick 50 freshmen, 50 juniors, 50 sophomores, 50 seniors, all right? At random, we pick those students at random once they were in their groups. Now, would that produce biased data? In other words, data that, again, is not representative of all the students, altogether? And the answer there, again, is no. That does not produce biased data. So this is another good way to collect data. All right. The next one, a systematic sample. Every kth individual is chosen. I don't know why they picked K, but hey, that's what they picked. So this letter here can be any number. So let's say they wanted to do the same thing, and they said, well, you know what? we've got somewhere around 1,600 students at Auburndale High School, 1,700 students. Let's talk to 170 of those students. All right. So let's pick every tenth student, and they would just go down the list. All right. And what they do is they would go, nope, 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 tenth. Yep. Let's pick that student. And then nope, 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 nope. Yep. And they picked that 10th student. And they just did that all the way through. All right. So if they picked every 10th student, would that produce biased data? And the answer is nope. This is another good way in order to collect data. Another example of this is, let's say a manufacturer is manufacturing, I don't know, they're making weed whackers, all right? Those things you use to trim your grass in the yard. And they say, well, on the assembly line, we make, 2,000 of these a day. We're going to take every 50th one off the line and test it. You know what I mean? That means your K is 50. Um, well, that's perfectly fine. That's a systematic sample. All right. That's a perfectly fine way to do that. A convenience sample. A selection of individuals is based on the ease of reaching them. So, for instance, another example, let's say we were all back at the high school in our classroom, and you wanted to figure out again what the favorite soft drink is, what favorite carbonated beverage is for all the students at Auburndale High School. Um, it, let's say you just picked out your class. All right. So you just walked around your classroom to the people that were there because they're easy to talk to. They're right there. Right. You don't have to go searching for anybody. You don't have to go hunt anybody down. And you just talk to those 15, 20, 25, 30 people in that one classroom. All right. That's called convenient sampling. Now, do you think that would produce biased results? Yes or no? All right. Yes or no? And let me give you another example before you answer. Let's say you wanted to find out students' um, opinion on the lunches in the cafeteria. Would you want to go to the cafeteria and talk to all the students in the cafeteria and not talk to the students that are in the media center during lunch, and not talk to the students that are sitting outside not eating during lunch, and not talk to the students that are seniors and they actually get to leave campus before lunch and they eat lunch out somewhere else? Do you want to Would that produce biased data? And the answer is yes, that would produce biased data. All right. Convenience sampling is never good. You never want to get data from this, so you really don't want to collect data through convenience sampling. You don't want to just talk to certain people because it's easy to get the information from them. All right. Another example of convenience sampling might be, um, you know, manufacturing. Again, let's say someone is manufacturing uh, light bulbs or something like that, and you just walk over there, and the last 20 your job is to test light bulbs, and you're supposed to, test 20 of them a day at a manufacturing plant, and you just walk over there at the day's almost over and you really haven't done much all day long, and you just grab the last 20 light bulbs that have been made off the shelf, and then you go test those. That's not good because there might have been a that that those light bulbs may not be representative of the entire run that was manufactured all day long at that plant. All right, next way, volunteer sampling. It selects individuals who decide to participate in a response to an open invitation. So let me give you an example of volunteer sampling. So let's say um, a company like McDonald's sends out their survey. Anytime you get a receipt from McDonald's, it has a survey on the back, on the receipt. And if you fill it out, they give you a code, and then you get like a buy one get one quarter pounder or egg McMuffin. Usually, I think is what it is. That is called volunteer sampling. All right, who decides whether to participate in that survey or not? You do. All right, the person holding the receipt does. Now, would you, out of let's say 100 people that went through the drive-through, and then you had certain people that participated in that survey, do you think that only the people that participated in the survey, their data matches up with every single person that came through that drive-through line, or that restaurant? And if the answer is no, then you have to say that this is going to produce biased data. Volunteer sampling always produces biased data. What you're going to get is you're going to get extremes. You're going to get people that are extremely supportive of whatever that issue is, or people that are way on the other side. You're not going to get anybody that's in the middle. So, volunteer sampling is not a really good way to collect data. It really produces biased results. You know, I liken it to those commercials you see on the TV all the time from like Geico. It says, well, the average, person that switched to Geico saved this much money for insurance. Yeah, guess what? Nobody switches to Geico because it costs more. So, of course, everybody that switches to Geico is going to save some money, because otherwise, why in the heck would they switch? All right. All right, so let's take a few practice problems here. It says use the following information to answer the question below. So we've got a bunch of students here. They are from Harry Potter, I guess. Never really watched the movies too much. And what house they belong to, and they've been assigned a random number. A random number. It appears that this list is alphabetical. All right. So it says Professor Dumbledore is trying to determine the percent of students who know how to perform a cheering charm. To do this, he wants to use a simple random sample of 5 students. How could he collect this sample? So just think about it for a few seconds, guys. How could he collect 5 random students here out of this list? All right. So think about the different ways that we talked about. I think the best way would be just to do a simple random sample. What you would do is you would take every single one of these students here, all right, take their numbers, drop them into a hat or use a random number generator. Let's say the first random number picked is 3, all right, well, now they're going to talk to this person, all right, and then, you know, another random number and boom, 7 pops up. So now they pick this person and so on, okay? That's one way you could do it. You could also break these down into, all right, we're going to pick one random person from here, one random person from here, one random person from here, that kind of thing. This is clustering. We could put each, you know, uh, put everybody in the certain house together, and we're going to say, hey, we're going to pick one person from each house. Now, that might not be so good here because you got only 2 Hufflepuffs, I guess it is. So they got to, if you're only going to pick one person out of these 2, they have 50% chance of being picked. Where down here, we got 1, 2, 3, 4, 5, 6. So they've only got a 1 in 6 chance of being picked in Gryffindor. So, but simple random sample would work great for this particular question. All right. Here's a couple more. Determine the type of sampling technique used for each situation and identify any problems with that technique. All right. So we're talking about whether it's cluster, systematic, stratified, simple random. It says divide the class into 4 groups: freshman, sophomore, junior, senior, and take a random sample of 2 students from each group. Guys, which one is that? That one is called stratified. Why is it stratified? Because everybody that's in each group has something in common. Everybody that's in the first group are freshmen. Everybody that's in the second group, sophomore. Third group, junior. Fourth group, senior, and so on. This is stratified sampling. Okay. The only way that this might be a problem is if, uh, like, let's say there's only 2 freshmen in the class, and you're going to pick 2 students from each group. Both of those freshmen did not, they were definitely going to be picked. Okay. Now, if you had, like, let's say 10 seniors in the class, well, only, the seniors only had since you're going to pick 2 out of the 10, the seniors only had a 1 in 5 chance of being chosen. So not everybody has the same chance. So that is, there's a problem right there. So you do have to be a little bit careful sometimes with these stratified sampling. Okay. Priceline.com randomly emails a customer satisfaction survey for certain transactions done on its site. Customers choose to either respond or not. What sampling technique is that? Sampling method? That is called volunteer sampling. Who decided on whether they were going to be a part of this survey or not? The customers do. The customers choose to either respond or not. Is there a problem with this? All right. Absolutely, there's a problem with this. the only responses that Priceline is likely to get is going to be responses that, from customers that had uh, just an outstanding experience or customers that had a very, very, very poor experience. If they had just an average experience, yeah, everything went fine, it's no big deal, maybe a minor problem, they're not going to get responses from those customers because they aren't going to be, they don't care enough about the situation in order to respond. Um, Number three, you are trying to select 25 students to represent your school for an upcoming interview with a local paper about their feelings about the changes to school lunches. Which of the following is the best sampling method in order for the views to be representative of the school? Again, you're only going to select 25 students, but you want their views to be representative of the entire population of the school. So, which of these would be best? A, selecting one of the classes from the school since they are each made up of 25 students. So, however many students there are in the school, you're just going to go select one class and you can say, okay, guys, you're going to talk about the school lunch in the paper. All right. Or B, select the last 25 students in line for the school lunch. Or C, send out a survey to all students and pick the first 25 that respond. Or D, randomly select 25 students through a drawing from which all the students are entered. So, of course, hopefully you guys see that this here would provide the least amount of bias. Okay. So all of the students are entered in the drawing and you're going to randomly select 25. All these other ones have bias problems. Okay. This one, not all classes are the same. This one, last 25 students that are in line for school lunch. That's only the students that are in line for school lunch. So that doesn't work out very well. Sending out a survey to all students and picking the first 25 to respond. That's volunteer sampling. So again, that's not really good. But this is the one that really, stands out as having the least amount of bias. All right. And finally, the last part of what we're doing before you get into your um, questions for this week to finish them up. The last, check your understanding. Researchers are interested in the best way to prepare for an AP exam. 200 students will be randomly assigned to use one of the following four treatments. So since it's 200 students, I guess we're going to put 50 students in each group. So 50 of the students are going to review class notes. 50 of them are going to review class notes and attend a review course. 50 of them are going to review class notes and study from a prep group, and 50 of them are going to review notes, attend a review, and study from a prep book. So, part A, we are going to design an experiment and discuss the proper use of randomization. I already started talking about the experiment. We should divide the students up into groups of 50. We could use any sort of sampling, like let's say you could assign a random number to each student, and then the first 50 numbers that came up would be students who would be assigned to treatment one. And then the next 50 students that came up would be students that assigned treatment two. The next 50 that came up would be assigned to treatment three. And then treatment four would be the last 50 students that somehow did not come up, and they would be each, now you'd have those. The potential lurking or confounding variables that might be out there, again, those might be some other things out there that could be affecting what's going on here. One of the things that I can think of here is some students, like let's say a student got put into the review class notes group. Well, maybe that particular student would do a lot better if they were involved in you know, a prep book group or something like that. So, or maybe they would do better in this group. So the problem is not all students are the same. The different learning styles might be a lurking or a confounding variable here. All right. Um, how could the experiment be modified to control for gender? All right, so controlling for gender, what you would want to make sure is you would want to make sure that, like, let's say that 100 of these students are male and 100 are female. Well, then you would want to have 25 and 25 in each group. You wouldn't want to have any of these groups be, heavily male or heavily female. You'd want to split it up equally. All right, or if let's say there's only 40 female, or I'm sorry, let's say there was 80 females and 120 males. Well, then those 80 females, you'd want 20 in each group. and then the 150 males you want, you know, 30 in each group. Um, whatever number would add up to the 200 students. So you'd end up with, the same proportions through each group. You wouldn't want any group to be, gender heavy one way or the other. All right. And so, guys, we are now at the end of this weekly lesson. You don't need to watch the Algebra Nation videos if you don't want to. This is why I was doing this for you this week. Friday, this coming up week, is a holiday. So I'm not going to set that as a due date. I'm actually going to set the following Monday. So you guys should be starting this on April 6th. So that means April 13th, I think it is, will be the due date for this assignment. But um, just try to get it done as soon as you can, guys. Have a great week. Again, a couple other things, guys. If you need to call me on the phone, I did send that information out. I don't have the number in front of me right now. I'll send it out again. There's a way that you can get a hold of me, but I'm only going to be available Monday through Thursday this week because Friday's a holiday, from 11 to 2 p.m. every day, from 11 a.m. to 2 p.m. every day. You can call that number and get a hold of me if you need to. If you have any questions on any of the stuff that we talked about, please ask those questions, and I'm going to try to make another video that goes over questions that our students are having. If you have the question in your head, it's probably in somebody else's too. So, but I'm going to be collecting all those questions, and then at some point later in the week, I'll put up a video covering those questions that you guys might have. Okay. So, guys, again, I wish we were back in the classroom, but we're not. It is what it is. And, just try your best on this, guys. Get on there. Don't fall behind. We don't have that many days left. All right. All right, guys. See you later. Bye.